I want 2 buns, 2 patties, some tomato, hold the ketchup. So building your packet is simply saying, I want IP this, dest that, flags this, and send the stuff on, and it figures it out. So if any of you remember way back when you were using whole applications to send LAN attacks against Windows boxes, it's now a Python one-liner. Okay? So really quickly, like I said, LR grabs the packet through IPQ, decodes the packet using SCAPI, allows you to fiddle with it, and then sends it through. At this point, we were supposed to do our demo of the first demo, which was simply doing a Google request for one thing and having the proxy transform it. Unfortunately, our wireless is shot, so we're restricted to only demos that we can do locally. But that one actually works, and that one should work pretty trivially, right? You're not changing the packet payload size, you're substituting foo for bar, and everything goes through happily. The problem starts to come in when you start changing your payload size. Okay, why is payload size changes interesting? Well, obviously you can recalculate your checksum, but one of the problems is TCP sequence numbers. Okay, really quickly, if you do a Google, it's actually shocking how many people explain sequence numbers just incorrectly on the internet. Okay, and a whole bunch of people do it incorrectly in some books. And that's because if you take the typical explanation of TCP sequence numbers, you have guys saying, well, your SYN packet goes through, you pick an initial sequence number, that host adds 1 and in order to ACK it and sends the stuff back. Okay, now this is clearly wrong. The remote hosts takes into account the size of the payload of the traffic that you've sent through and adds that to the sequence number ACK. Now this causes a problem for us when we're mangling the payload size, right? Because effectively what we're doing is causing a desync between the client and the server. So actually what SPLR needs to do, okay, and that totally gratuitous picture of Charles was thrown in because Charles worked on this Visio diagram last night. Okay, that's Charles. Okay, so what SPLR has to do once we modify content length is watch that the sequence number, which was initially X. Okay, so what's happening in this picture? The client sent through a request for foo. It gets to our proxy, which then transforms it to a GET request for foo, foo, foo. Okay, at this point, the problem that's going to happen is the remote server is going to ACK us, but he's already 6 bytes ahead of what the client expects. Okay, so once we get to this stage, we are forced to handle all of the sequence numbers for both the ends. Basically, all we do is fake out both sides. As the packet comes into us, we either add or subtract to the sequence numbers so that both the client and the server still happily think that they're talking to each other with good sequence numbers. Okay, at this point, we were supposed to show you the second demo, which was substituting foo for SensePost does Las Vegas, and that also should work if we were able to get to Google. Okay, so we're going to have to skip it and go to local demos at this point. The point is, if we inline, we're now in a position to do lots of other interesting mangling. Okay, it becomes interesting for client-side fuzzing. Okay, send data with a perfectly valid client. As data comes back from the server, grab the packet and inject a whole bunch of junk into it. Okay, the client's not expecting it and it goes horribly, horribly wrong. Okay, it's interesting for any sort of lame client-side security, and if you talk about lame client-side security this year, the first thing that has to come up is VNC's authentication bypass. Okay, so we'll take a look at it really quickly. So VNC had this problem where client connects to the server, they both agree on what protocol they're talking. The server says, hey, you can talk to me with authentication type 2, 3, and 4, and the client's supposed to pick one of those authentication types. Okay, the problem that VNC made, or the mistake that they made, is they didn't check that the client was choosing an authentication type that they offered up. So the server would say, I'd like authentication type 2, 3, and 4, and the client says, okay, give me 1, which happens to be no security, and the server happily accepts it. Okay, so if we take a really quick look at this, what we've got here is just an ordinary Linux box, okay, and we should be able to xVNC, if I could spell it correctly. Okay, we should be able to xVNC4 if I could spell it correctly, okay, to the win2k box. Okay, and at this point it gives us a password prompt. If we gave it a password prompt, it would say, that's cool, now you can go through. Okay, and instead what we're going to do is start redirecting our traffic through our proxy. And this time we're going to run our Python script that says, hey, as this traffic comes through to you, substitute the acceptable authentication type with authentication type none. Okay, so that's listening, and this time if we xVNC, you should see that it happily goes through without any authentication. Okay, so the only thing that the proxy has done is stripped out authentication on the way through, and both client and server are happy. And for the duration of this, you should get funny sounds, but your traffic should work perfectly okay. It drives you a little nuts, but other than that, it's all good. Okay, so really quickly, because I suspect I'm rapidly running out of time. Okay, we're going to go to another example. Okay, so if we're doing that, the last example is that obviously we're in a perfect place to alter headers. Okay, so any of your TCP or IP headers. And so we're looking for a good example of this, and we ended up looking at the old FreeBSD ECE bug. Okay, basically FreeBSD bumped into this problem. If I can just ask my beautiful assistant to hold my mic so that it doesn't drown your ears and it makes him look busy. Okay, so FreeBSD had this problem where you pretty much, if they had any firewall rule set dropped, installed that made use of an any established except, if your packets had the ECE flag and the ECW flag tagged on, packets would sail through the firewall. Okay, just out of interest, SensePost released an exploit for this in 2001. It took 270 lines of C to make it happen. Okay, using SPLR, it takes 20 lines of Python, 4 of them are comments. Okay, so really quickly, what we're going to look at here is with your regular firewall. Okay, I tried a telnet to the FreeBSD box on port 22, and it gives me no joy. Just to show you guys, I'm not sure if the text will come through, but here's the FreeBSD box, currently unhappy. Okay, and if you check out its firewall rule set, okay, let's just make that clear. Okay, there's an allowed TCP from any to any established, and there's a deny all. Okay, so this should be allowing no traffic through unless you are doing ACK tunneling or something like that. Okay, so you see we get no joy on 22. We could try web browsing to it, but quite predictably it should give us no joy there either. Okay, and so again, all we do is go to LR, and this time we tell it, hey, tag the ECE packet onto everything that goes through. Okay, and this time a telnet should come back and give us our header, and surfing to the box should give us joy as well. Okay, so at this point, all we've done, or the demos that we've seen, have just been mangling the payload with size alteration, and now mangling the header. Okay, and the joy of it, like I said, is that it's really simple Python script, so you can fiddle with it as you want. I'll jump back to the presentation and take the mic from Rulof. Thank you, Rulof. Okay, other uses for it, things that make it cool. Like I said, Scapy makes it perfectly cool dissecting the packet. So literally I get a packet in and I say, here's a packet, what's its UDP payload? And it says, well, this is the UDP payload. And I say, well, let's change that resolver from foo to bar and send the packet on. The joy of hooking on to a really clever project like Scapy is that as more people add more packet intelligence to Scapy, it's less work for you. So actually changing a DNS return packet isn't just substituting the string. You need to alter RR records, you need to alter checksum records. I don't understand any of that stuff or need to. I just tell Scapy, build me a good UDP packet and please send this through. Okay, the one thing that it is missing is pretty much what you'd find if you were doing normal debugging in terms of an int3. Okay, so typically a client sends its packet, you start fiddling with it, you send it to the server, but by that time the client's timed out, okay? the client sent its request and it was waiting and you took too long editing it. Okay, so one of the things that we want to do with LR that we haven't gotten around to yet is to possibly start playing with TCP window zeros. Okay, we're putting it out here just because someone here might start fiddling with it quicker. But the thinking behind it is simple. What we figure is, as the client sends its message and we intercept it, we spoof a message to both the client and the server with a TCP window, or TCP window 0. Okay, pretty much telling both the client and the server, we're too busy now, don't talk to us. Okay, both the client and the server go into a hold state, you mangle your packet, and once you're done, you send both of them a window update and allow traffic to go through again. Okay, it's untested, so you could laugh at me horribly once you go back home and try it, but that's how it goes. Okay, so at this point, you should have a trivial, easy-to-use alternative to packet mangling. The tool should put you in a position to mangle payloads and headers. More importantly, you should see that it's a whole lot easier to fiddle with stuff at that level than some of the black magic voodoo stuff that's been going on till now. We'll put LR, which is a whole bunch of the ugly scripts with samples, up on sensepost.com. So you guys can go there and download it. Should be cool. Back to the good-looking one.
Then, as a conclusion to the talk, the following: if hacking is an art, then then your tools are really your brushes, right? But a monkey with a brush is still a monkey. So in our courses, we say it's not about the tools, it's about the thinking. It's about the thinking, it's about the methodology. It's not about the tools, it's not about the tools. But, it's nice to have nice tools at the end of the day as well. There's a difference between a paint roller and a fine-tipped paintbrush. We hope to be creating some of the ones here and some of the ones there as a rollers and as fine-tipped paintbrushes. But again, having a paintbrush doesn't make you an artist either. So tools available there should be available there on www.sensepost.com/research. Any parting words? Mail us questions, comments, all goes to research@sensepost.com, and we thank you very much. Sorry, if there's any questions from the audience now? We always do this, so then we don't have to.
Yeah. So the question is, does LR have regex functionality? And pretty much, because of how it's built, you get to say, take the payload to string, payload regex, foo bar, and you're good to go. So absolutely.